So what I was teaching? Thermometry. Morning, good morning. Okay, so I think I was discussing some problems. Okay. So now time is less, so not audible. Am I audible? Jyotika. Okay. So now all the scale we have discussed, few problems discussed. Now one more problem I will discuss, then I will start with a triple point. Okay. So find temperature in Kelvin scale at which Fahrenheit and Celsius scale have same reading. Okay, so we have to find the temperature in the Kelvin scale at which Fahrenheit and Celsius scale are showing the equal or same reading. Okay, so first we have to check it is possible or not. Okay, then we can find the values. So we have to find the temperature in the Kelvin. So first we have to find that temperature, means that reading at which Fahrenheit scale will show the same and Celsius scale will show the same. Because like suppose body temperature Fahrenheit shows different, Celsius scale will show different, but we have to find the temperature at which they will show equal temperature. Okay, so what is the conversion factor? 233.15 minus 40 degrees C. Very good. So we can say what? C by 5, that is equal to what? F minus 32 by 9. Okay, from the TSI thermometric scale identity, when you equate, because you want to convert one scale to the other. Now here they are saying C and F, they are showing the same reading. So suppose I am writing C is equal to F is equal to X. Then what we can say? Now 9X, that is equal to what? 5X minus 160. Then from this you will get the 4X is equal to minus 160. Then X what you will get? Minus 40. So we can write minus 40 degree C, or we can write as a minus 40 degree F. Okay, so at minus 40 they will show the equal reading. Okay, but that we have to convert into the Kelvin scale. So when you will convert into the Kelvin scale, you have to add 273.15. So in Kelvin scale, minus 40 plus 273. But in the numerical problem, we ignore what? 0.15. Otherwise, you can see the according to the option we can take. Okay. So then you will get what? 233 Kelvin. Okay. Okay. So who will say at what temperature the Celsius scale and Kelvin scale will show the same reading? At what temperature Celsius and Kelvin scale will show the same reading? At what temperature Celsius and Kelvin scale will show the same reading? 1. Okay, 1, 233. Okay. Celsius and Kelvin. 233 Kelvin. Answer is 1. Next. Not possible. That is the right answer. It is not possible because mathematically you can say, otherwise logically also you can say, how 160? Array. Here, what is the problem? How? This when you multiply 5, 32 5s are 32 5s are 160, I think. Surya. Okay. Okay then. So I am saying the Celsius and Kelvin. So suppose what is the relation we have? K is equal to C plus 273. Okay. No problem. K is equal to, I am saying K and C are equal. So K and C are equal. So X is equal to X plus 273. Okay, x cancel out. It means what I got, 273 is equal to 0. So when the value of the 273 is 0, then Celsius and Kelvin will show the same reading. Otherwise, by the logic also you can say, so that is not possible. Okay, because to convert the reading of the Celsius scale in a Kelvin scale, we have to add always 273.15. So when we have to add always 273.15, then how it is possible that they will show the equal reading? Getting my point or not? Okay, so that's why Celsius and Kelvin scale can never show the same reading. Okay. Now, so this is the like conversion of one scale into the other scale. It is over now. Now in a one NCERT they have given one problem. Like earlier we were using the steam point and the ice point as a reference temperature. But now in the modern thermometer we have replaced those reference temperature and we are using the triple point of water as a reference temperature. What is the reason? So we know that boiling point and the freezing point, it varies with pressure. Like 1 atmospheric pressure, boiling point is of water is 100 degrees C and the freezing point is 0 degrees C. But when we change the pressure, like in a hilly area, water boil at the lower temperature. In a pressure cooker, water boil at a high temperature. So boiling point and freezing point change with the pressure. So that was a problem with the two reference point, ice point and the boiling point. So that has replaced by the triple point of the water. Okay. So no need to go more detail. The only one relation we have to learn, like when we are using the triple point as a reference point. Okay. So you can write as a note. If triple point of water is taken as reference temperature, okay, then how we can find the unknown temperature? That relation you have to remember. I'll explain what is the meaning of X and what is the meaning of XTR. Okay, so here this relation we have to use when they are saying the triple point they are taking as a reference. Okay, so what is the meaning of X? What is the meaning of T here? So at any temperature T, this X is the thermometric property. X is the thermometric property. That may be what I said in the first class. Thermometric property may be pressure, may be volume, may be resistance. They can use any thermometric property. The property that changes with temperature. Okay. So X is here what? Thermometric property. Okay. So like suppose I am taking the pressure gas thermometer. Pressure gas thermometer means I am using the pressure as a thermometric property. Volume gas thermometer, it means I am using the volume as a thermometric property. Understood or not? Okay, so X, which thermometric property I am using, X I will put that. Okay, so what is the X? What is the XTR? So at a temperature T, thermometric property is X. At a temperature T, thermometric property is X. At the triple point, thermometric property is the XTR. Like that way you can remember T, then thermometric property X. TTR, then thermometric property is XTR. We have to equate, suppose they will give at the triple point of the water, pressure of the gas is this, and at any unknown temperature, pressure is this. What is the unknown temperature? So means they have given the thermometric property at any unknown temperature. X they gave, XTR they gave. TR we know that triple point of the water is what? 273.16 Kelvin, not 15. It is not 0 degrees C. It is a 0.01 degrees C. Triple point. So this is the triple point of water in Kelvin scale. Okay. So this TR we know that X they will give, XTR they will give. From that we can find the unknown temperature. Everybody got or not? Okay. So X is the thermometric property we can write here at temperature capital T, and XTR is thermometric property at triple point. Okay. Any other is like here you are using in a Kelvin scale, then T you will get in a Kelvin. Any other scale also you can use. So according to that, T and TR you will put in that scale. Getting my point? If TR you are putting 273.16, then T you will get in a Kelvin. Okay. Okay. So suppose I am giving oxygen gas volume at triple point is equal to, not volume, pressure at triple point 1.2 into 10 to the power 5 Pascal. Okay. At unknown temperature, pressure is equal to 1.8 into 10 to the power 5 Pascal. Okay. Then find unknown temperature. So I have given the pressure, means I am using the pressure as a thermometric property. So I have given the pressure at triple point and I have given the pressure at unknown temperature. Okay. Now I am asking what is the unknown temperature. Tell what? What is the answer? So T upon TR means 273.16. That is equal to thermometric property at temperature T. T is the unknown temperature. That is what? 1.8 into 10 to the power 5 upon 1.2 into 10 to the power 5. Okay. So this and this cancel out. This you got 3 by 2. Now T what you will get? 3 by 2 into 273.16. Answer you will get in Kelvin. What is the answer? Tell fast. 408.74. 8 or 9? 4.9. Same question, how you are getting the different answer? 409.74. 409.74. Okay. So can I believe you? Okay. So 409.74 Kelvin. Calculation you will do. Okay. Completed. Okay then. One more question in the NCERT exercise they gave. We are taking the two hypothetical scale, that is a and B. Okay. In the scale A, triple point A is equal to 200 A and triple point in scale B is equal to 350 B. So they are asking what is the relation between temperature in the scale A and temperature in the scale B. Okay. So to any hypothetical scale they have given A and B and they have given the triple point in the scale A. Means when I'm using the scale A, so scale A is showing 200 degree A. 200 A means 200 degree A. And when I'm using the scale B, it is showing 350 degree B. Means same temperature I'm measuring, but their readings are different. A is showing 200 degree A, B is showing 350 degree B. Then we have to find the relation between temperature. Are Surya, 3 by 2, how I got? Are 8, will cancel decimal. So 6 3s are 8, 6 2s are 12. So 3 by 2 you will get. Okay. So first you have to start with mathematics. Okay. So here they have given this relation and asking if I'm measuring like C and F relation. Suppose I ask. So what we write, C is equal to 9, F is equal to 9C by 5 plus 32. Similarly, they are asking what is the temperature relation in a scale A and a scale B. That is the meaning of TA and TB. Okay. So here directly we can use the triple point concept. What I said, T upon TTR, that is equal to what? X upon XTR. So if the temperature, they are measuring the same temperature, so thermometric property will be like, suppose volume of the gas here in or volume of the air I am measuring here. So whether I use the Celsius scale or Kelvin scale, their reading will be different, but volume of the air will be constant. Okay, so this thermometric property will be same, maybe the scale reading will be different. So this I can equate with this. I will take a scale A, and that I can write as a T upon TR of scale B. Okay, from this we can equate these two. So temperature in the scale A by 200, that is equal to temperature in the scale B upon 350. Then from this we can say what? Temperature in the scale A is the 4 by 7 TB. Okay, so TA is equal to 4 by 7 TB. Everybody got or not? Okay. Surya, now you will ask how 4 by 7 came. Ask. Okay. No, sir. Thank you. Okay then. So this thermometry is over now. So we have to start now the thermal expansion of solid. So if anybody has doubt, they can ask, because little bit I will go fast because weekend portion we have to complete. Okay. So expansion of the solid, some basic idea maybe you have. Expansion means what? When we are increasing the temperature, like suppose I have the very solid rod. Okay. When I increase the temperature of the rod, what will happen? The rod may have what? This will have the atoms or molecules. Okay, they are arranged. So when we are increasing, so they are absorbing the heat and their thermal energy increases. So that's why their vibration increases. So at equilibrium, when what will happen? They arrange in the large distance. So all the distance between the all atom increase. So overall, what you will see? Length of the rod increase. Okay, so this is the thermal expansion. Understood or not? That basic everybody know. When we increase the temperature, every molecular distance or atomic distance increases. That's why overall the solid get expand. Okay. So in a expansion, suppose I am saying about the linear expansion. So first I am writing this. We can categorize expansion of the solid in the three, like linear expansion, areal expansion, and volume expansion. Liquid and gas, we cannot define the linear expansion and areal expansion. Why? Because liquid, there is a length of the liquid. There is no meaning of this. So in a liquid and gas, we define only volume expansion. But the solid has well-defined length, area, and volume. That's why in a solid, we define three expansion: linear, areal, and volume. So we can say this is a linear expansion. Then volume expansion. Areal first we can write. And then volume expansion. Okay. So you will get the expansion. Suppose I have the any rod. Okay, its original length is L. If I increase the temperature, more temperature I increase. More temperature if I will increase, so what will happen? The rod will expand more. Yes or no? Less temperature increase, less expansion. More temperature is increased, more expansion. Then we can say what? Expansion in rod, that delta L is directly proportional to the delta theta, change in temperature. Delta theta, here we are taking the change in temperature. When you will increase the temperature, delta L means positive. Delta theta positive means you are increasing the temperature. When you are increasing the temperature, length will increase. When you are decreasing the temperature means delta theta is negative. Delta theta negative means delta L negative. Delta L negative means length is decreasing. That is a common sense, everybody know. So when we are increasing the temperature means delta theta positive. Delta means final minus initial. So when delta theta positive, then delta L positive means length will increase. If delta theta negative, then delta L will be negative, it means length will decrease. Okay, understood? So according to the problem, increase or decrease, you will take the sign of the delta theta and delta L. Okay, now similarly, if I am taking the small rod, if I increase the same temperature, then what will happen? Small rod will expand less. More length you are taking, so more expansion you will observe. Why? Like when the rod length is more, it has a more number of atom. So when you increase the temperature, all atomic distance will increase, so overall you will get more expansion. But when the rod is shorter, then you will get the less expansion. So from that we can say what? Delta L is directly proportional to the original length. Okay, yes or no? Okay, so then by combining these two, so we can say delta L, proportionality I am removing, that is the proportionality constant, we put alpha L into delta theta. Okay, delta theta is the change in temperature. Okay, so alpha is the proportionality constant, that is called the coefficient of linear expansion. Okay, everybody got? So this is the only formula that you have to remember in this chapter. Delta L is equal to L alpha delta theta. If delta theta positive, delta L you will take positive, it means length will increase. If delta theta is negative, then delta L will be negative, it means length will decrease. Okay, I will tell about property of alpha and all. Okay, completed. So I'm writing these expansion all together. So linear expansion, areal expansion, and volume expansion. Okay, so linear expansion delta L, what I can write? Delta L is equal to L alpha delta theta. Okay, similarly areal expansion we will write about delta A. Delta A I can write as what? Now in the areal expansion what will happen? Area we can write simple form L into L square. So when you do the area you are taking L square. So in a rough I am saying A is the L square. So delta A by A, what I can write? 2 delta L by L. In the error we have learned. Okay. Now delta L by L we can replace by the above formula. Delta L by L is the what? Alpha delta theta. Okay. Then here what we will get? Delta A by A is equal to 2 alpha delta theta. Then delta A what you will get? 2 alpha delta theta into A. Now if you compare with the linear expansion, so delta L was L alpha delta theta. Here what I am getting? Delta A is equal to A delta theta. In the place of alpha I am getting the 2 alpha. That 2 alpha we take as a coefficient of areal expansion, that we represent by beta. So beta we take as a 2 alpha. And what is a beta? Coefficient of areal expansion. So remember that beta is equal to 2 alpha, that beta we take as a coefficient of linear expansion. Okay, areal expansion. Beta is the coefficient of areal expansion. If you want to write, you can write this. Okay. Then here delta A, what I will write? That A into beta into delta theta, where beta is the coefficient of areal expansion. Okay. Now similarly, volume expansion, what I can write? Delta V is equal to V. Same, delta L is equal to L alpha delta theta. Now delta V, what I can write? L will replace by V. So delta V is equal to V. Here I will take the gamma into delta theta. So what is the gamma? Gamma is equal to 3 alpha, and gamma is called coefficient of volume expansion. Beta we can write as a 2 alpha. Okay. So similar formula, delta L is equal to L alpha delta theta. By that way we can write the delta A and delta V. Okay. Next, if they are asking what is the fractional change in the length, what is the percentage change in the length. So fractional change or percentage change, what you will find? Delta L by L, delta A by A, delta V by V. So that what we can write directly. So delta L by L, that is a fractional change. And this we can write as the alpha delta theta. Similarly, here we can say what? Delta A by A, that is equal to what? Beta delta theta. So sometimes they will give the percentage change. So fractional change you will multiply with 100. And here we will take delta V by V, that is equal to gamma into delta theta. Okay. Okay. Then what is the formula of the alpha? Alpha you will get delta L by L into delta theta. Okay. From the above formula, delta alpha we can find delta L by L into delta theta. Similarly, beta we can say what? Beta is equal to delta A by A into delta theta. And gamma we can say what? Delta V by V into delta theta. Gamma formula we will use in the liquid and gases also. Okay. Completed? Okay. Now from this unit of alpha, what I can say? What is the unit of alpha? Temperature inverse. So we can say here delta L and L, they will have the same unit. So they will have same unit, so that unit will get cancelled out. So alpha will have the unit of the temperature, 1 upon temperature. So we can say unit of alpha, that is the 1 upon temperature. Okay, so it may be 1 by degree C or 1 by Kelvin or 1 by Fahrenheit. Okay. Similarly, here beta also same unit. And gamma also has the same unit. Okay. Now, if I'm asking, like, what is the properties? Now we have to discuss the properties of alpha. So alpha was the proportionality constant. So if I'm saying that I'm taking the more length of the rod, what is the effect on alpha? If I'm taking more length of the rod, what is the effect on alpha? No effect. Why? Alpha was the proportionality constant. Okay, when you will take the more length, then delta L will be more, but alpha will not change. So alpha is the property of material. Alpha is the property of material. For a given material, it will be constant. In the numerical problem, we will follow. But in the NCERT one, like we know that when the temperature will change, so alpha value will change for the same material. Okay. But in the numerical problem, if they are saying like iron, so iron will have its fixed value of alpha. We will take the iron value, iron alpha is fixed. If they are saying copper, so copper has its own value of alpha. Steel has its own value of alpha. So alpha value we will take, it depends on the material. It does not depends on the length. Okay. And for any temperature change in a numerical problem, we will not consider the change in the alpha. Okay. Understood or not? So alpha is the property of material. It does not depends on the length. Okay. For a given material, alpha will be constant. Okay. So alpha is constant. Okay. So in the last, I would say that one graph they have given in NCERT, that is a variation of the alpha with temperature for copper, and already they have asked that question. So that I will discuss later. But here we have to take what numerical problem. If they are using the same material, so same element, then we will take the same alpha. Okay. Number 2. If I'm saying if the unit of alpha I am changing, unit of temperature I am changing, so value of alpha will change or not? If unit of alpha I am changing, so value of alpha will change or not? No. Yes. No. Change. Okay. Change. Okay. So it may or may not. It may or may not. Like suppose I am giving the example. Alpha, so first I am writing alpha value may change with change in unit of temperature. May change. Okay. So like suppose I am taking the alpha value. Alpha is equal to 1.8 into 10 to the power minus 5 per degree C. Alpha value I have given 1.8 into 10 to the power minus 5. Okay. Now I am asking what is the value of alpha in per Kelvin? What is the value of alpha in per Kelvin? Same. Yes or no? Why? Because here this delta degree C, this degree C does not came due to the temperature. It came due to the temperature difference. It came due to the temperature difference. Why? If the formula, if you see the alpha formula, in the denominator delta theta was coming. Okay. In the denominator delta theta was coming. So delta theta in a Celsius and Kelvin, their magnitude are equal. We have learned the conversion factor delta C by 5 is equal to delta K by 5, means delta C and delta K will be equal. So this is not the temperature. I will not replace 1 degree C is equal to 273 Kelvin. Here 1 degree C, what I am using as a unit, 1 degree C is equal to what? It is a temperature difference, and 1 degree C temperature difference is equal to 1 Kelvin. Okay. Got it or not? Okay, so this I can say what? That is equal to 1.8 into 10 to the power minus 5 per Kelvin. The value will be same. Here value does not change. But suppose I am asking in a degree per degree Fahrenheit. If I am asking per degree Fahrenheit, then it will change or not? Then it will change. Why? 1 degree C temperature difference and 1 degree F temperature difference are not same. Okay, so here I am taking the temperature difference, so delta C. Okay, so 1 degree C I have to write in the degree F. So we know the relation, 1 degree C temperature difference is equal to 1.8 degree F. So who will say what is the answer in degree F? What is the answer in degree F? 10 to the power minus 5. 10 to the power minus 5. Very good. Okay. Then here what we will take? 1.8 into 10 to the power minus 5 and 1 degree C temperature difference. Already we have done the problem. 1.8 degree F I can write. Now 1.8 cancel out. So what you got? 10 to the power minus 5 per degree F. Okay, so from Celsius to Kelvin, what we have seen, it is same. It is not changing. But when we are using the Fahrenheit, it has changed. Okay. Completed. So some solid, we know that they contract on heating. They contract on heating, like rubber is an example. So the solid that contract on heating, their alpha value, we can say their alpha value will be negative. Their alpha value will be negative. So solid that contract on heating, their alpha value we can take as negative. Okay. Or they can ask, like, if alpha value is negative, then what does it mean? So alpha value negative means that solid will contract on heating. Okay. Okay, then now small problems we will do first. Okay. Who is that? Okay, then. Okay, so if percentage change in area of iron plate is 4%, then find change in temperature if alpha iron is equal to 1.2 into 10 to the power minus 5 per degree C. So if percentage change in the area of the iron plate is 4%, then find change in temperature if alpha iron is equal to 1.2 into 10 to the power minus 5 per degree C. Tell fast. One point 1.6 into 10 to the power 5. Ashwak, I have given the percentage change. So percentage in the area means delta A by A into 100. That quantity has given 4%. Okay. So delta A by A into 100, that has given, delta A by A is not, fractional change not given, percentage given. Okay. Then I can say delta A by A is what? 2 alpha delta theta. That you can write as 4 into 10 to the power minus 2. This 100 you will shift this side. Okay. Now alpha value they have given 1.2 into 10 to the power minus 5. Okay. Into delta theta that I want to find is equal to 4 into 10 to the power minus 2. Then now delta theta, what we can write? 4 and this cancel out, that is a 2. So 2 into 10 to the power minus 2 into 10 to the power 5 will go up, and then 1.2. Okay. Then delta theta, what you will get? 2 into 10 to the power 3 by 1.2. Okay. So 1670 degree C. Okay, 1670 degree C. So I have not calculated, you are calculating. Everybody got right calculation, 2000 upon 1.2. So when you will divide 1670, okay? Okay then. Completed? Okay, good. Then next, 2 cube as ratio of sides are 4:5 and their alpha are in the ratio 5:4. Then find ratio of change in volume or same temperature change. Tell fast. So ratio of the side of the two cubes is the 4:5 and their alpha are in the ratio 5:4. Then find the ratio of the change in volume for same temperature change. Okay, first who will say, like suppose I am saying for any solid, ratio of the alpha is the 5/4. What is the ratio of the beta of the solid? What is the ratio of beta of the solid? Same, and same gamma. Why? Because ultimately 2 and 2 you will multiply in a numerator and denominator, it will get cancelled out. So ratio of the alpha of any two material will be equal to ratio of beta of the material is equal to ratio of the gamma of the material. Okay. So answer is the 16 by. Okay, so for this problem now, they are asking the change ratio of the change in volume. So change in volume means delta V1 upon delta V2. So delta V, what is the formula? V gamma delta theta. V gamma delta theta. So original volume into gamma into change in temperature. So V1, I am taking original volume for the one is V1 gamma 1 delta theta upon V2 gamma 2 delta theta. Delta theta cancel out. V, this is the cube. So what is the V1 by V2 you will take? Volume of the cube is what? Side cube. Side cube means then you can take A1 by A2 whole cube into gamma 1 by gamma 2 I can write as directly alpha 1 by alpha 2. Now side ratio they have given 4:5. Then 4 into 4 into 4 by 5 into 5 into 5 and the alpha ratio they given 5/4. So 5 and 5, 4 and 4 cancel out. What we got? 16:25. Okay. Completed. Now I am thinking that I can complete the syllabus, this weekend syllabus. Okay, very good. Okay. So just one note. Here we are dealing with the relation what? Alpha is to beta is to gamma is equal to 1:2:3. Okay. So that type of solid means I am taking the L square or area, I am taking L into B. So what we are considering, the solid is expanding equally in all the direction. Solid expanding equally in all the direction. But it is possible that it may increase, its length may increase in particular direction more and some direction less. So that type of solid is called the anisotropic solid. So a solid that expands equally in all the direction, that solid is called isotropic solid. And isotropic solid, alpha is to beta is to gamma is equal to 1:2:3 we can take. But the solid which does not expand equally in all the direction, they are called the anisotropic solid. And anisotropic solid, we cannot say the alpha is to beta is to gamma is the 1:2:3. So in a problem, if they are not mentioning isotropic, anisotropic, so we will consider like a isotropic. Okay, but if they are mentioning that it is an anisotropic solid, then according to that we will think. Understood? So isotropic, they expand equally in all the direction, and anisotropic, they expand different in different direction. Okay. So isotropic solid, we can say alpha is to beta is to gamma is equal to 1 is to 2 is to 3. And for anisotropic solid, we can say gamma is equal to what? Alpha x plus alpha y plus alpha z. Means alpha x is what? Coefficient of linear expansion in the x direction, coefficient of linear expansion in the y direction, and z is the coefficient of linear expansion in the z direction. If it is isotropic, then alpha x, alpha y, alpha z will be equal. Then gamma, what you will get? Alpha plus alpha plus alpha, that is 3 alpha. Okay. Completed. Okay. So some more question will do. Maybe this type of question they have given in so many books, that is a very common question. So here, like a one ring it is. There is a material is there. Okay. Here it is a open. So they said that is a ring. Its radius is the r, and the open portion is subtending an angle phi at the center. Okay. Thickness of the ring, I gave the d, variable d. Okay. And any point I am taking randomly, A and B. The distance between the point A, B, I have given x, and radius of this ring I have given r. So when we increase the temperature, then what is the effect on y, phi, r, x, d? All will increase. Only angle remains same. Okay. So remember one thing, like suppose radius I am talking about, x I am talking about, d I am talking about, y I am talking about. So these all are the linear distances. There are the distances. So that all the distances we apply the concept of the linear expansion. They will change by the linear expansion. Okay. So we can directly apply the formula of the linear expansion in the case of the y, r, x and d. So what will happen when we expand? It will become like this maybe. Okay. So radius will increase, x will increase, okay, y will increase, the thickness will also increase because distance between the 2 points, what I said, atom is there, so atom they are expanding, so distance will increase. So y, r, x and d increases. Okay, like what the r I can write? R dash is equal to what? R into 1 plus alpha delta theta. Okay, similarly x I can say what? X into 1 plus alpha delta theta, that is a x dash. So all the distances will change by the alpha is negative, Vikram, that they will say particularly, because if they are not mentioning, always we will consider like a expansion. Otherwise they will mention it. If they are not mentioning, means we have to consider it is a expand on, because rare solids are there, they contract on heating. So most of the cases, if they are not mentioning, then we have to consider expansion when we are increasing the temperature. Okay. Similarly, x, r, everything we can write. Okay, got it? Now for the angle phi, we know that angle is equal to what? Arc by radius. Okay, so what is the arc? Initial arc was y and initial radius was r. So we can say what? Phi is equal to y by r. Okay. Now after increasing the temperature, suppose angle become phi dash. So phi dash, what I can write? Nu y and nu r upon nu r. So y, what I will put? Y dash by r dash. That is equal to what? Y into 1 plus alpha delta theta, and r, what I can write? R into 1 plus alpha delta theta. So this and this will get cancelled out. You will get what? Y by r, and y by r is equal to what? Phi. Okay. So this is increasing, but ultimately the angle is what? Angle is same. Okay. So all the quantity will change by the linear expansion, but angle will remain same. Understood or not? Same problem like suppose if they have given the disc, in that disc there is a hole of the diameter d. So what is the effect on the diameter when it will increase, when the temperature will increase? What is the change in diameter? Increase by delta theta. Then diameter of the hole will also increase. So diameter of the hole will be delta d whole. We can say what? D into alpha into delta theta. Like delta L is equal to what? L alpha. Most of the problem they ask in the delta. So delta L formula is what? L alpha delta theta. So diameter is also the linear length, linear. So we can say what? Delta L means delta of the diameter of the hole. That is equal to L alpha delta theta. Understood? So one question directly they have given on this formula in the NCERT exercise. They given the diameter, they given the alpha, they given the temperature change. They are asking what is the change in the diameter. So directly after putting the value, we will get the answer. Yes or no? Okay. So this change formula everybody has to remember, because most of the question they have given on the change. Okay. Okay, then this is now completed. One question more we'll discuss. If there is a wheel has a diameter 2.243 meter and diameter of ring they have given. Ring is that is equal to 2.237 meter. Okay. So they have given the diameter of the wheel is the 2.243 and diameter of the iron ring they have given 2.237. Suppose that is a wheel. Okay. You want to fit the iron ring on it. You want to fit the iron ring. So what you will do? First you will heat the ring so that it will get expand. When it will get expand, you will put on the wheel. Then after that, when it will cool down, it will tighten the wheel. Okay. This type of this we use in a cart and all. Okay. So wheel has a more diameter, ring has a less diameter. So first you will increase the temperature of the ring. When it will get expand, then you will put on the wheel and then it will get cooled down, so it will tighten the wheel. Okay. So here the diameter of the wheel they given 2.243 meter and diameter of the ring they have given 2.237 meter. So from the data you can see iron ring, that ring has the diameter lesser. Okay. Now you want to put the ring on the wheel. So how much temperature you have to increase? How much temperature should increase of the ring on the wheel? if alpha iron I am giving, alpha is equal to 1.2 into 10 to the power minus 5 per degree C. Tell fast, what is the answer? If the diameter of the wheel I have given 2.243 and the diameter of the iron ring I have given 2.37, how much temperature you have to increase to tight the ring on the wheel? So how much diameter we have to change? So delta D, we can say delta D is equal to what? 2.243 minus 2.237. Then what you will get? 0. 0.00. How 0.005? 0.006 meter. Okay. So we have to change this diameter 0.006. Yes or no? Okay. Now delta D formula we directly know. Delta D is equal to what? D into alpha into delta theta. Now who will say what is the D value you will put here? You will put 2.243 or 2.237. Here D value what you will put? 2.237 or 2.243? 2.237. Why? We are increasing that diameter. We are increasing that diameter. So initial diameter is what? We are increasing the diameter of the ring. So initial diameter of the ring is what? 2.237. Okay. Then put the values. So here delta D what I got? 0.006. That is equal to 2.237. Meter and meter will get cancelled out. Alpha 1.2 into 10 to the power minus 5 into delta theta. From that you will get the temperature change. Who will say the answer? So 2.237 you can take approximately for the calculation. 2.3 you can take as a 2.24 into 1.2 and divide with 600. That you will get answer in a degree C. 250 approx. Okay. Completed. Suppose in the same problem they are asking how much temperature decrease, how much temperature has to decrease so that suppose here wheel they made from the iron, and how much temperature decrease, so you will decrease the radius or diameter of the wheel, you will decrease the diameter of the wheel, and delta theta in that case it should be negative. Why? Because when we will decrease the temperature then it will contract. Okay. So in NCERT exercise one problem they have given on this shaft wheel. So how much temperature has to decrease, you can do that problem. Okay. Completed. Okay, then. Okay. Now next is the equivalent alpha. So equivalent alpha means what? Okay. So equivalent alpha is alpha depends on the material. Okay. Before telling the formula, first I will say what is the meaning of alpha. So suppose I have the two rod. One has the length L1, other has the length L2. It is made of the material alpha 1. It is made of the material alpha 2. Sum of all alpha, how? So just listen. L1, that condition you have marked up, this is not applicable here. Okay, Ashwak. Now listen. Equivalent alpha means what? This equivalent concept you will learn in the thermal equivalent conductivity, equivalent resistance, equivalent alpha. So many places you will learn this concept equivalent. Okay. So here I am talking like I am asking the equivalent coefficient of linear expansion. Means I am talking about the expansion. Okay. So here we will deal with the expansion. So here suppose I am using two composite rod. One rod has the length L1, other rod has the length L2, and they are made of the different material. One has the coefficient alpha 1, other has the coefficient alpha 2. Okay. So like equivalent resistance concept, if I have the two resistances R1, R2, then they are connected in series. So we say what is the equivalent resistance in the series combination R1 plus R2. It means what? If I replace these two resistance by the single resistance, so what resistance I have to put so that it will behave same as the combination? What resistance I have to put in the place of R1 and R2 so that it will behave like a same in the circuit? So one resistance equivalent value, what you will say? R1 plus R2. So if I remove these two resistance by the single, so what is the equivalent resistance I have to put? R1 plus R2. So here I was talking about resistance. Now here I'm talking about expansion, because coefficient of linear expansion. So these two rod you have, composite rod, length L1, L2, alpha 1, they are made of different material. Okay. When I increase the temperature, increase by delta theta. Okay. So when you increase the temperature, this will expand, this will expand. Suppose it expanded by delta L2 and it expanded by delta L1. So what is the total expansion you got? Total expansion is the delta L1 plus delta L2. Yes or no? Up to this it is okay. Two rod both are expanding, so that's why total expansion delta L1 plus delta L2. Now, what is the meaning of equivalent? If I replace both rod by the single rod. So if I replace both rod by the single rod, that single rod, what is the length you will take? That single rod, what is the length you will take? L1 plus L2. You will take the length L1 plus L2 because ultimately I have to take the same length. So equivalent rod will have the length L1 plus L2. How L1 minus L2? If I'm making the same combination, so L1 plus L2. Okay. Now, if I had one rod I'm taking, so this rod will made of one material. This rod has to be made by one material. Earlier it was the two rod of the different material. But now I'm making the one rod, so that rod will have only one material. Its material I can take alpha equivalent. This material alpha I can take alpha equivalent when this combination will have equal expansion of this composite rod. When this rod will have equal expansion equal to the composite rod, then I can say the material alpha is the alpha equivalent. So this is the meaning of alpha equivalent. Means composite rod, whatever it is expanding, the same expansion the single rod must have. Then its material alpha is called the alpha equivalent. Understood? Yes or no? Okay, so when the same temperature change you have done, you increase the temperature by delta theta, then suppose it got expanded by delta L. Okay, then I can say what? Delta L must be equal to the delta L1 plus delta L2. Okay. Now, for this rod delta L, what I can write? Delta L formula is the what? L alpha delta theta. What is the L of this rod? L1 plus L2. Okay. What is the alpha? Alpha equivalent into delta theta. That is equal to delta L1 is what? L1 alpha 1 delta theta plus L2 alpha 2 delta theta. Now delta theta cancel out. Now choice is yours. You can mark up the formula directly. Alpha equivalent is the what? L1 alpha 1 plus L2 alpha 2 upon L1 plus L2. Okay. Like three rods are there, so L1 alpha 1 plus L2 alpha 2 plus L3 alpha 3 upon L1 plus L2 plus L3. Okay. Got it or not? Any problem anybody has? Okay. So one directly formula based question I'm saying, you will say the answer. Suppose two rod I have, one has the length L, other has the length 3L. It's alpha is alpha. It is a 2 alpha. What is the equivalent alpha? Tell fast. What is the equivalent alpha? What is the equivalent alpha? So L1 alpha 1 means L alpha. L plus L2 alpha 2 means 6L alpha upon L1 plus L2 means L plus 3L, that is a 4L. Now the L cancel out, 6 alpha plus alpha 7 alpha, so 7 alpha by 4. Okay. Okay, Vikram calculated fast, very good. Now calculation is. Priyanka, how 7 by 2A? Again by mistake. Why there is a silence? 7 alpha by 4 we are getting, na? Okay. Okay then. Okay, now next thing is what? That already they asked the question based on this concept. Suppose I have the two rods. One has the length L1 and it is made of material alpha 1. Other rod, its length is L2 and it is made of material alpha 2. Okay. Two different rods, they are made of the two different material. Okay. Now if I'm asking what is the difference of the length? Difference of the length is what? L2 minus L1 or mod of L1 minus L2, you can say. Which one is more? From that you will subtract. So difference of the length of the rod is what? L2 minus L1. According to the figure, L2 is more. So L2 minus L1 is the difference of the length of the rod. Now if I change the temperature of both rods by the same amount, I change temperature. Okay. So when changing the temperature of the both rod by the same amount, if I am saying their difference is not changing, if I am changing the temperature of the both rod by the same amount, but their difference of the length is not changing, what is the condition for that? And they ask the directly question, what is the ratio of the length ratio they given, alpha ratio they ask, like that, this for this condition. Okay. So they have given the different length, they are made of different material, but if I'm saying by changing their temperature same amount, their difference does not change. Their difference does not change. What is the condition for that? So initially they have the length L1 and L2. Suppose you increase the temperature. When you increase the temperature, its length become increased by delta L1 and its length increased by delta L2. If delta L1 and delta L2 are equal, after increasing the temperature, any temperature or increasing or decreasing the temperature, if their expansion are equal, so when one expand X, other expand X, so what will happen? When you take the difference, X and X will get cancel out. X and X get cancel out. So what will happen? Difference will remain same. Difference will not depend on temperature. Understood or not? So for this type of problem, what we have to take? We have, when they are saying the difference is constant, it is independent of temperature. Difference is independent of temperature. So for that, what we have to do? We have to equate their expansions or equate their contraction. Means we have to equate the delta L. Getting or not? Okay. Then if their difference of length is independent of temperature, then what we can say? Their expansion must be equal. It means we have the condition what? Delta L1 is equal to delta L2. Delta L1 what I can write? L1 alpha 1 delta theta, that is equal to L2 alpha 2 delta theta. Same temperature change, so that's why delta theta cancel out. So what is the condition I got? L1 alpha 1 is the L2 alpha 2. Okay, or I can say what? L alpha is equal to constant. Okay, so remember that condition and read the question carefully. If they are saying their difference of the length of the rod is independent of the temperature, then you will apply this concept. L1 alpha 1 will be equal to the L2 alpha 2. Understood? And from this we can say what? L alpha is equal to constant. Okay, L alpha constant means, suppose I am saying the two rod made of different material, they have the equal length. Okay, if their difference of the length is independent of temperature, two rod made of different material, they have the different length. If their difference of the length is independent of temperature, their difference of length is independent of temperature, which rod you will take longer? Which rod you will make longer? More alpha or less alpha? So longer rod you will made from the material whose alpha is less. From this we can say L alpha is equal to constant. So in that case, if they are saying the length is independent of temperature, then I can say L alpha will be constant. L into alpha will be constant. So longer rod I will make the material whose alpha is lesser, and shorter rod I will make with the material whose alpha is more. Understood? Okay. Okay then. So simple that they will give L1, L2 and they will ask what is the ratio of the alpha. So directly we can use this relation. No need to do the question on this. Okay. Completed. Now small, so many topics are there. One is the scale is there, and effect of the temperature on the time period. Okay. Bimetallic strip I will cover in the next, that is it will take the 2 minutes. So I have not discussed in all the batches, so bimetallic I will discuss in the next class. Okay, so 1 or 2 topics I have to discuss now. One is the scale. Okay, so effect of temperature So if I go in detail, it will take so much time. But in short, what we have to know in this case, because one question they have also given in the exercise. Suppose I have one rod. Okay. This rod length I am measuring by any scale. Okay. Scale is made of suppose metal, and metal that may expand. Okay. So I have the one scale, metal scale. Okay. For the scale, they use one word, calibration temperature. Calibration temperature means the temperature at which it will give the correct reading, or the temperature at which the scale has constructed. Again, I am repeating, what is the calibration temperature? Calibration temperature is what? The temperature at which any device has constructed. So at that temperature, it will give the accurate reading. Like for the pendulum clock calibration temperature means the temperature at which clock will give the right time. Clock will give the right time, or the temperature at which clock has constructed. Understood or not? So calibration temperature. What is a calibration temperature? It is the temperature at which any device has made, or we can say the temperature at which it will give the right reading, because at the temperature in which you have constructed, at that temperature it will give the accurate reading. Understood or not? So what is the calibration temperature? The temperature at which any device will give correct reading, or it has constructed at that temperature. Okay. Okay. So suppose scale I have constructed at any temperature, and that temperature is the, I am writing here, calibration temperature of scale is equal to theta. Okay. Now, or theta naught. So I am using the scale at the temperature theta. I am using the scale at the temperature theta, and this theta is greater than theta naught. this theta is greater than theta naught. Now first listen, suppose I'm not considering the expansion in this object, no expansion, okay. I'm not considering effect of temperature on the object. Suppose I'm taking the wooden rod, I'm not considering any expansion, okay. So if I measure the wooden rod length at temperature theta naught, at calibration temperature, if I measure the length of the wooden rod at the calibration temperature, so what the reading I will get? That reading will be accurate reading. Yes or no? Say yes or no. Okay, so suppose I am measuring the length and this I am taking, suppose I am getting 25 centimeter. Assume it. When I am using at calibration temperature theta naught, so I am getting the length of the rod, wooden rod at calibration temperature is 25. It means actual length of the rod is 25. Actual length of the rod is 25 because I am using the scale at the calibration temperature theta naught. Okay, so you got the actual length of the rod is 25. Now suppose I am using the scale, listen carefully. If I am using the scale above the calibration temperature, scale expansion we have to consider. Object expansion we don't have to consider, scale expansion I am considering. If I am using the scale above the calibration temperature, then what will happen? It will measure less than 25 or it will measure more than 25. If I am using the scale more than calibration temperature, it will measure less than 25 or more than 25. Less than 25. Why? Because when we are using at high temperature, so scale got expand. Scale got expand, so each division got expand. So each division got expand, so 25 will not be here. This division will come. On the scale, it is a mark now 1, 2, 3, 4, 5. So 25 will not be here. 25 will shift to the right. So in that case, what will happen? Maybe 25 shifted here. Okay. Then what you will observe? You will observe the length is what? Shorter than 25. Length is shorter than 25. So at that temperature, you will get the reading less than actual. Are say yes or no? Okay. Otherwise, if they are saying at above the calibration temperature, we are measuring the length of the wooden rod. Above the calibration temperature, we are measuring the length of wooden rod is 20 centimeter. Actual length of the rod will be less than 20, more than 20, equal to 20. Tell fast. Above the calibration temperature, length of the wooden rod is measured 20. Above the calibration temperature, length of the wooden rod measured 20. Then actual length of the rod will be more than 20, less than 20 or equal to 20. More than 20 because I am using at above calibration temperature. Above calibration temperature, what the reading I will get, that reading will be lesser. That reading will be lesser. So actual length will be what? More than that. So at above calibration temperature, I am measuring 20. Above calibration temperature, I am measuring 20. It means I am measuring less than actual. So actual length of the rod will be more than 20. By that logic, you can get the answer or not. Are say yes or no? Okay. Similarly here, if I am using temperature, this scale below the calibration temperature. So below the calibration temperature, what will happen? This 25 will shift to the left. So in that case, you will measure the length more than actual. More than actual. Understood or not? So reading will be less than. So measurement less than actual. But if they have given the measurement at that temperature, so rod length will be more than measurement. Okay. More than actual. Okay. Everybody got or not? By this logic, we can get the answer. If they are asking the less than or greater only, they are not asking the exact values. So then we can get the answer by less than or equal to by this analysis. But maybe some of you understood, they can apply the logic in the exam, but somebody don't know, they cannot apply. So they need some formula to analyze. Okay. So one formula I am saying, from that formula, you can get the exact values also. You can analyze the length will increase or decrease, or what is the exact value of the length, what is the measurement at that temperature, we can get from that formula. Understood? So L observed, so the L observed means it is the observed length or measured length at any temperature. That is equal to L naught into 1 plus alpha rod delta theta upon 1 plus alpha scale delta theta. So in the numerator, actually, if you see, so that is the what? L naught into 1 plus alpha rod delta theta. It is a what? Actual length of the rod. After the expansion, what we write? L into 1 plus alpha delta theta. So that I have written in the numerator. And denominator 1 plus alpha s into delta theta. It is a one division of the scale. Okay, that we can derive, but here derivation not much important. So alpha rod is the alpha of the rod, and alpha s means alpha of scale. Okay, L observed means measured length at that temperature. At given temperature, and delta theta is the change in temperature. L naught is the length of rod at calibration temperature. Length of rod at calibration temperature. So these data you have to remember. Okay, L naught is the length at calibration temperature, means it is the actual length of the rod. Okay, now fast I will explain how to use this formula. Suppose the same problem. Okay, one thing, suppose they are saying don't consider the expansion in the rod. Don't consider expansion in the rod. So alpha rod, what you will take? 0. Okay, if they are saying don't consider the expansion in the scale, then alpha scale we will take 0. Okay, according to that value we will put. Got it or not? Temperature increase means delta theta you will take positive. Temperature decrease means delta theta you will take negative. Okay. Now previous problem, how we can analyze by this formula. So previous problem, what I said, suppose I am using the scale, I am not considering the expansion in the object. In the rod I am not considering expansion, but I am considering the expansion in the scale. Previous problem, what I said, 25 greater than 25. So I am not considering the expansion in the rod, I am considering the expansion in the scale only. Okay, so no expansion in the rod, so this will be 0. So L naught is the actual length. Okay, L observed is equal to L naught. So in that case, if alpha r is equal to 0, then L observed, what you will say? L observed is equal to L naught upon 1 plus alpha scale delta theta. Okay, getting or not? Now suppose observed length above the calibration temperature. Above the calibration temperature means delta theta is positive. Okay, so delta theta, you can write here, delta theta positive above calibration temperature. Okay, now delta theta is positive, alpha scale positive, so denominator you will get more than 1. Denominator you will get more than 1. When you multiply with what? L observed. So what is the length you observed? You observed length 25. At any temperature you observed the length 25. That temperature was more than calibration. You can see this problem. I am observing more than calibration temperature. Yes or no? So when I am using more than calibration temperature, means this quantity is positive and it is more than 1. More than 1 into 25, you will get more than 25. So actual length will be more than 25. Yes or no? If I'm using above the calibration temperature and I observe that length is the 25, observation I'm getting 25. So what is the actual length? Actual length is the L naught. So L naught you will get more than 25. Like that way you are measuring below the calibration temperature, you will get the length will be what? Lesser than 25. Understood or not? Okay, if suppose scale and rod, they have like one exercise problem in the NCERT, you can try by own. In exercise, they have given rod and steel scale. Both are made of same material. Both are made of same material. Then what will happen? This term and this term will get cancelled out. If they are made of same material, so alpha rod, alpha scale are equal. So this and this get cancelled out. So observed length will be the calibration length. Observed length will be the calibration length. Yes or no? Okay, but actual length will be what? More than observed. Why? Like suppose the actual length is L naught. I'm using above calibration temperature. Actual length is L naught. Above calibration temperature, what will happen? It will thermally expand. So actual length will come more than calibration length. But observed length will come calibration length. Why? Alpha scale and alpha R are same. Okay. So just try that problem, exercise problem. Okay, if you have doubt, you can ask in the next class. So I will try to give up to this. I will ask that syllabus. A small portion, one small portion is remaining. If possible, class I will see. Okay. Otherwise, up to this you have to prepare. Okay. Okay. Bye bye. Bye bye. Okay then. Bye bye.